Hi and assalamu alaikum to everyone. How are you? I hope you all in a good of health during the MCO period. Today I will deliver the lecture session via this video. I hope all of the students will watch and listen to this video as for the replacement of face-to-face lecture session. Let's begin with our lecture. Next, I will list the learning outcome for Chapter 3. At the end of this topic, all of the students should be able to: first, understand material classification, atomic structures, energy band, covalent bonds, and conduction in semiconductors. Secondly, student need to understand the concept of free electrons and holes as carriers. Then, the third one is students must have the ability to explain types of semiconductor, intrinsic and extrinsic. Students required to explain doping process for the semiconductor material. Explanation of the formation of p-type, n-type material, also the key points, the learning outcome. And the last is to describe the process of depletion region in semiconductor and p-n junction formation. Please enter your text here. I will introduce the sub-chapter of the Chapter 3. In the introduction of the semiconductor chapter, there will be atomic structure, covalent bonding, free electrons, and energy level. For the atomic structures, several elements and points need to be understood. In general, the construction of every discrete solid-state electronic device or IC begin with highest quality semiconductor material. These semiconductors are a dedicated and special class of elements which having conductivity between good conductor and insulator. Here we can categorize the semiconductor into two classes of semiconductors material. First is single crystal category. It reflected to the repetitive crystal structure, as example germanium and silicon. The second is compound category. It is built with a construct of two or more semiconductor materials of different atomic structure. As an example, gallium arsenide, cadmium sulfide, gallium nitride, and gallium arsenide phosphide. But, most frequently used in electronic devices which we can find easily is germanium, silicon, and gallium arsenic. Here is the atomic structures example for these two categories. Single crystal structure on the left while the compound is on the right-hand side. The silicon represented a high and good atomic structure by utilizing all themselves upside down, while the compound type constructed the good atomic structure by a combination of two type of material which are the gallium and nitride. Speaking of the atomic structure, here we should know how the atom itself is built. In the starting point of all things in the earth, atoms are bound together to form a crystalline structure. If we look deeply into this small tiny atom, fundamentally, the components of atoms are from the three elements, electron, proton, and neutron. In the lattice structure, neutron and protons form the nucleus. Okay, Now that a look at image on your left-hand side, electrons appear in fixed orbits around the nucleus. This figure is illustrating the Bohr model of atomic structure. To see this structure based separately by type of material, here silicon has 14 orbiting electrons, which is in the most left figure, germanium has 32, gallium has 31 and the rightest arsenic has 33 orbiting electrons respectively. Based on the periodic table of elements, silicon has the number of 14. Therefore, by having 284, the last number as 4 reflected the valence electrons. In this case, silicon and germanium has 4 valence electrons, gallium has 3 and arsenic has 5 valence electrons. In this case, this valence electron can also be named with their number of valence electron available in one element. For the element with 4 valence electrons is called tetravalent, and those with 3 are called trivalent, while those with 5 are called pentavalent.
Okay, thank you for watching the NMZH channel. So hopefully you guys enjoy and get the benefit knowledge from this video. Thank you. Assalamualaikum.